Alright, welcome back to another session of learning Unity, and I just started up the Unity IDE, or not IDE, but the editor. So we're just gonna wait for that to load up. While that loads up, I'm gonna load up the VW website so I can start learning. Cool. So I think where we last left off, we were learning about the world pixels per unit or something like that. And let me try to review. I think we loaded up. Alright, cool. So, oh yeah, and the last thing we did was also putting these sprites into our game. So as a review, let's see what happened. We did learn about the pixel per unit, and we can do that by changing the size of the camera, which is, I'm assuming, the height. So if I said 7, it'd probably be just right here. You know, that's right. So yeah, so it's from this camera would be the center, and it goes 6 units up and 6 units down with a total of 12 as the height. And we want to kind of make our sprites adapt to that pixel per unit to make everything more consistent. Like, I mean, in my head, I'm thinking that usually when you're creating your own sprites, you'd probably think about that like as you design it. But I guess, like, for me, if I'm just getting random sprites, random images, I need to consider the camera size so that nothing appears too big or too small. So I'm going to continue the video. So I guess I'm still trying to understand, like, why does the sprite go or why does it shrink when we increase the pixels per unit? I guess that's something I still need to wrap my head around. But for now, I think I'm just gonna accept that if we want to increase or decrease the size, it's inversely proportional to the pixels per unit. So if I want to decrease an object or a sprite, then I would need to increase this value here, which we probably have to do for the ball too. I think we need to make it consistent with everything, so maybe 128 would be the solution as well, and then the block too, 128 by 128. So there isn't a consistent value that all of these sprites should have, because he placed it as 300. That does look better. Oh, well, he changed it again. So for the block, he did 256, which is, so I assume it's gonna shrink this by half. So considering its native size is 128 by 128, 256. Yeah, so I guess it made it kind of like 1/4 of it. I wonder why the arrows look like this. Is it because of the camera again? Shouldn't be, considering they are kind of far apart, so it shouldn't be like that. That's kind of weird. Oh, now it shows the problem. Oh, that's kind of, oh, that was a glitch. Now we're gonna learn about rigid body and colliders. So let me just change this just to make it look better. Let's try it. Oh, it's good. Alright, let's go back to the so I think it'd be the main camera. Cool. So we have dynamic, which is saying that the object will react to like real, like not real world like physics, but like the physics essentially. It will change as the game is playing. So if we interact with this ball in our game, the I guess the properties, the physics properties of our object will react according to our physics that we create for the game, I think. So the difference, so kinematic and dynamic are very similar in the sense that, you know, the object is moving as the game is going. But with dynamic, we don't have that control. It's based off the, I guess I'd say, the physics that we made for the game. But for kinematic, we want to be able to control where that object is going. So it's like I'm still trying to grasp my head around it, but I think it's kind of like if you made a gun and you're shooting bullets, the bullet, you still want the bullets to move, but like I guess if you're going with the basic like normal bullets that doesn't have like other like physics applying like drag force or whatever, then it'd just be like moving in one direction, and that's what we want, right? And then I guess that's what the kinematic portion is. We control where we want the rigid body to go, as opposed to in dynamic, it's the placement of the object is controlled by the overall like engine, I guess, like the calculations of how the body is impacted will be calculated through the engine rather than what we want. I'm still trying to grasp my head around it, but that's how I see it. So one is kind of you giving it control to the engine, and then the other one is I have control over where the object should go. So he didn't go over static, but I'd assume that it'll just stay still, like no physics would impact it, and it would just stay at its spot. But for this project, he did say that we were going to go choose dynamic because he wants the ball to go all crazy, and he did provide us a link. So let's go take a look at it. So it's the rigid body 2D Unity document. So I'm just going to take a quick look. So dynamic, kinematic. So dynamic, a dynamic rigid body 2D is designed to move under simulation. It has the full set of properties available to it, such as finite mass and drag, and is affected by gravity and forces. A dynamic body will collide with every other body type and is the most interactive of body types. It is most common to use for things to move. It is also the most performance expensive body type. Oh, I mean, I understand why, because it's gonna do all the calculations. So maybe for kinematic, it would be like controlling a character, because we're like pressing right, and then it's still moving, but we still have some control over it. Do not use transform component to set the position or rotation. Simulation positions and going to velocity. You can change this directly via voices. Let's go with kinematic. Under simulation, but only under very explicit user control. So it's still affected by gravity. Wait, well. Oh, kinematic isn't affected by gravity. It is faster and less demand than a dynamic. That's something worth considering, but I think as a beginner, I don't think I really need to pay attention to it that much. Just trying to learn about the uses of them. But definitely in the bigger game, I assume you really need to use kind of like a hybrid of them to kind of make your game more efficient so that it runs on a variety of machines. Kinematic is designed to be repositioned explicitly via the move position or move rotation. Use physics, queries, and tech collisions and scripts to decide how the rigid body 2D should move. So move via its velocity, but the velocity is not affected by. So yeah, I guess that would be a good example. Would be a character that you're controlling. Like in reality, you know, if we're like we have a human running, you know, the gravity will make them tired because of the stamina and all that, but it's usually not that effective. It doesn't get like applied, like, I don't know, it's kind of hard to tell. It's kind of explain, but like if our sprites don't have bones, I guess gravity will like squish them, but with a kinematic it kind of mixes both worlds. I don't know. A kinematic rigid body 2D does not collide with other kinematic rigid body 2Ds or with static. It only collides with dynamic rigid body 2Ds. Huh. Wait, it doesn't even collide with static? Really? Similar to static. I know static is just like staying still, because that's what it means. To not move under simulation at all. If anything collides with it, behaves like an immovable object, as though it has infinite mass. It's the least resource intensive. Having two static 2Ds collide is not supported. Makes sense. Alright, so let's just continue. I at least got an idea of it. And maybe as I test things out in the future, I'll probably get a better understanding of it. So the ones that don't have 2D, we can automatically assume for 3D objects. Pretty cool. Wow. So I assume there's like already default gravity value. What the? Oh, the gravity scale. Let's make it 5 and make it drop really fast. Ooh. So this is our challenge. We gotta add a box collider 2D to the block and position the block underneath the ball so that they can collide. So let's go to the block add a box collider 2D. So this is a static rigid body, I think, but he didn't mention about using it, so maybe we don't need it. Let's actually do want to understand what is a rigid body. Body, an object under control. Oh, it places an object under control for the physics engine. The differences are that 2D objects can only move in the XY plane. They can only rotate on an axis perpendicular to that plane. Alright, so we added the box collider, and then we just need to move it underneath the circle, the ball. So it should stop right here. It should land on it. Nice. Does it bounce? I think it kind of bounces. Like it was colliding with it, but then it didn't really read the collision until later, so then it fixed itself. Let's check out Collider. Maybe. Oh wait, Collider 2D. Yeah. Components define the shape, the purpose, physical collisions. A collider, which is invisible, need not to be the exact same shape. In fact, a rough approximation is often more efficient and indistinguishable in gameplay. Colliders for 2D game objects all have names ending 2D. Collider that does not have 2D in the name is intended for use on 3D game objects. Note that you can't mix 3D game objects and 2D colliders. Cool. He said that we're going to be using the polygon collider for the paddle. So the next step is adding physics material. Let's the physics material is used to adjust friction and bouncing effects of colliding objects. So definitely you'll see the use of that. We're going to add a polygon collider 2D. Does it automatically adjust to it? No way. Really? It automatically adjusts to it? That's crazy. Well, it doesn't have to be perfect. I think that's good, because that's what they said. It's usually indistinguishable. Alright, we're just gonna edit. He's editing it, so why not? It's pretty cool. sort of. He's saying there's probably a tiny slope there, so we gotta really make it accurate. Let me just fix that real quick. Hopefully this works. Yep, that works. Cool. So now we're gonna add a folder for materials. Folder materials. He said to create a physics material to D, but I don't see. Oh, we have to go to 2D. There it is. Alright. So the challenge is to essentially give the ball a bouncing feature. Well, I assume we have to adjust the values of bounciness, so let's just make it 3. Might be too much, but we'll see. And then we go to ball, and then I remember in a rigid body we can add a physics material. So let's drag it there and see if it has any effect. Whoa, okay, maybe it was too much. Alright, maybe that was way too much. Let's change it back to maybe 0.5. That's no. Let's make that to 1. Yeah, it's better. It's better. I wonder. I mean, friction is. I forgot what friction was. I know it's like when two things are rubbing against each other, the negative force in the opposite direction or anything. But this is like, it's not really. I don't think friction's happening. Wait, is it rotating? Whoa. So I guess it still rolls a bit. Friction, we're just gonna leave it as the default value. And yeah, so I think that's good enough for today. So I'm gonna end it for today, and yeah, I'll probably continue tomorrow. So peace.